All right, today we're going to be doing piecewise functions. This is actually probably the hardest part of chapter 1, and it's not that hard. So we're going to talk about piecewise functions, how to go from a graph to the actual function, and then how to go from the actual function to the graph. So here we have a piecewise function that is graphed for us. Okay, this is what it looked like. Now these things I kind of have drawn in since then. But here we have -2 on the y-axis. This is 1, this is 0. There's a 1, and then I tried to scratch out the 2 because I wanted it a little higher. But anyway, so that's really 2 is that top point there. Okay, so that's what we have. And what we want to do is we want to write a piecewise function for this graph. Now, here's the problem. We really have 3 pieces, if you'll notice. We have the piece that goes left of -2, the x-coordinate -2. We have this v graph, which is what type of a graph is a v graph? Absolute value, good. And then we're going to have at 2, at x equals 2, we're going to stop that graph and start a new type of graph that goes over from there. Okay, and so that's what our graph looks like. These points where the graph changes direction are called parameters. Those are the key points as you do the graph. So usually I fill those in first on my function. I understand I've got 3 different parts to my graph. Some people may say I have 4 different parts and they would do one at 0, which you could do, by the way, because an absolute value graph is really 2 lines. So I could do this as a piecewise function with 1, 2, 3, 4 parts instead of 3. But I'm lazy, and so I always like to combine parts if I can. So I'm going to make that all one part. Mathematicians are inherently lazy. We always try and do the least amount of work. So that's what we want to do. But these parameters are really the key, and I can't stress that enough. Usually when kids mess this up, they don't think about the parameters. Think about where the graph is changing directions, and you need a different type of equation. I'm going to need a linear equation going left. I'm going to need an absolute value equation between these 2 points. And then I'm going to need a linear equation going right. So how do I find those equations? This is the key and kind of the hard part. So this one that is on the left is really the toughest one. Even though it's just a line, it makes you think about where you are. So this point is on the line, -3, -1. You go up 1, 2, 3, and over 1. So you've gone up 3 and over 1. So what will the slope be of this line then? The slope will be 3 over 1. 3 is the slope. Now, you may have forgotten how to do this because it's been a while. This is since last year. But you have an equation of a line, y equals mx plus b. You're like, oh yeah, I remember that. Slope-intercept form. Exactly. Well, what do the y and the x represent in slope-intercept form? They actually represent points on the line. This is the x-coordinate of a point, and this is the y-coordinate of a point. What does the m represent of the line? It's the slope. What does the b represent? It's the y-intercept. Well, in this case, I know the slope, it's 3. I know a point on the line, -3, -1. What I'm not sure of is where exactly is that going to cross the x-axis. Now, I know it's somewhere up there. It's obviously up, positive something, but I don't know where. So I've got to figure out where that would cross, because really the graph stops at the parameter when it's less than -2. So the way I find that is I simply plug in the point for y and x and plug in the slope that I figured out by looking at the line, up 3 over 1, and then find where it's going to cross, being the y-intercept. So I plug in the y, -1. Don't forget to put the y on the left. Kids mess those 2 up and then they mess up. Then I have equals the slope. The slope is +3 over 1, so that's +3. And then the x value, which is -3, plus b. Do not subtract those, multiply those. So therefore I have 3 times negative 3 is negative 9 plus b. Got to get the b by itself, so I add 9. B is 8. So the equation of this line, where it's going to cross up here, is really going to cross up here at 8. So now I can write the equation, y equals 3x plus 8. But that's only true if we're less than, going to the left of, negative 2. So that's what I put as my parameter when I'm writing a piecewise function. So a piecewise function has 2 parts. It has the function that represents a line or a parabola or a absolute value, whatever. Okay, and the function part goes on this side, the left side, and then it's going to have a parameter. And the parameter will go on the right side. The parameters, again, are where the graph changes direction from the function that was occurring. So this function is good and it works until I hit negative 2. Then the graph is going to change directions and use a different function to graph. Well, what's the other function that I've got to have graphed? So now I'm doing this middle part, absolute value. Notice the middle part will go from my parameter negative 2 to my parameter 2. So that's why I put my parameters first. I can list these parameters before I do any of the equation. I can just look at the graph and say, okay, it's going to change direction at negative 2. So x has to be less than negative 2 for the side that goes on the left. Has to be between negative 2 and 2 for the part that's between those values. And then it has to go right of 2. Now, how do I find this absolute value part? Well, I think about what I did yesterday. Okay, what is the vertex point? The vertex point is 0, negative 2. So the x value didn't go right or left at all, and the y value dropped down 2. So that's going to make an absolute value of x, and then minus 2. This minus 2 comes from that vertex point. Now, why do I have this 2 in front, though? Well, normally I would go up 1 over 1, but I've got to go up 2 over 1, up 2 over 1. So that a value, or the slope of the absolute value, has to be multiplied by 2. So I'm going to go, instead of up 1 over 1, I'm going to go up 2 and over 1. Up 2 and over 1. So this up 2 part is that a value in front, kind of the slope of the absolute value. So this is true, but only between negative 2 and 2. I can go left 1 and up 2, and left 2 and up 2, because the absolute value of a negative 1 would be a positive 1 times 2. That's why it goes up. Or the negative 2 times absolute value of negative 2, which would be 2 times 2 would be the 4. From the vertex, over 2, up 4. Okay, that's true, but only between negative 2 and 2. So I have my parameters of x being between negative 2 and 2. Then I have my function, y equals 2 absolute values of x minus 2. Excuse me. All right, now I do the last function, or the last piece, I should say. That's why they call these piecewise functions. The last piece of the function, which is when x is going to the right of 2. In other words, when x is greater than 2. That's the last parameter. As it goes out this way, what is it? Well, it's a horizontal line. That means y is constantly going to be 2. So that one, we have no slope. The slope of this is 0. And so therefore, my equation, y equals mx plus b, is y equals 2, because the slope is 0. So this one won't have an x on this side because it's a constant horizontal line. Okay? Now, the next part is going to say something like this. Graph, so this one started with a graph and we had to write a function. We can also start with the function and then you have to graph it. Okay? So let's start with this function and let's explain what it actually is saying. I always start with this parameter part, because the parameter part is really the key to graphing. Anything left of negative 2 is going to follow that line. Anything between negative 2 and 4 is going to follow this absolute value. And anything to the right of 4 will follow this line. Now, here's the key. don't mark the y-intercepts if they're not in the parameter. In other words, I can't mark the y-intercept of this line on my graph because this graph is only going to be true when it's left of -2. I can't graph the y-intercept of this one because it's only true when we're right of 4. So I'm going to graph those, and then I'll do the middle one in between. But let's graph the one that starts. Normally I would start at 1. Now I do mark that, but it's a light mark, so I can just kind of use it. And I'm starting at 1, and then normally I'd go down 3 and to the right 2. But do I want to go down 3 and right 2? No, I've got to get to the left. So if I keep going down 3 and right 2, and down 3 and right 2, I'm going to be clear. Who cares what it is over there? This is only true when we're left of -2. So I, instead of going down 3 and to the right 2, have done the opposite. Notice this slope, -3/2, is equivalent to up 3 and left 2. Isn't -3/2 the same as 3 over -2? Isn't a negative divided by a positive the same as a positive divided by a negative? Obviously that's true. So instead of going down 3 and to the right 2, I'm going to go up 3, 1, 2, 3, and to the right 2. That puts me at the point -2, 4. Now, why is it so important that I mark that point? Well, it's because that's the equal part of the piece that has the parameter left of -2. My other parameter is going to be clear over here at 4. So those are points I want to mark so that I know where I'm at those points. So notice I started at 1, and I went up 3 and over 2. 1 plus 3 is 4. That's how I got up to 4. And then I went left 2. That's how I got over to -2. Now I keep going up 3 and over 2, and I can keep going up 3 and over 2 as much as I want because it's always going to be true that this line is the graph as long as I'm left of -2. So that's what I mark on the left of -2. Now, on the right of 4, I'm going to mark this line. Well, what's the y-intercept of this line? It doesn't have anything there. Oh, it starts at 0. That's right. The slope is 1. So starting at 0, I'm going to go up 1 over 1, up 1, over 1, up 1, over 1, up 1, over 1. What point am I at? Well, I've went up 4, and I went over 4. So 4, 4 is the point that I'm going to hit at the parameter of 4. I can keep going up 1 over 1 and up 1 over 1 to the right as far as I want because it'll follow this line as long as we're right of the parameter 4. Now, I've got to graph the middle, okay, in between those two. So in between -2 and 4. It will follow this graph. Well, what's the vertex of that absolute value graph? This is what we did yesterday. The vertex is 1, opposite value of what's on the inside. So we're going to go right 1, and then we're going to go down what? 3. So I went right 1, down 1, 2, 3. Now there's no a value in front. So that means I'm going to go over 1, up 1, both right and left. So I'm going to go over 1, up 1, over 1, up 1, over 2, up 2, over 3, up 3, over 3, up 3, sorry, and left 3 and up 3. Now, why are those 2 points important? Well, because at 1, -3 being my vertex, I'm going to hit the parameter 3 to the right and up 3. So this point, which is one, two, three, 4. Sorry, 4, 4, 0, and this point, which is -2, 0, are the points that we'll end on when we hit the parameters of 4 and -2. So that's the graph of this piecewise function. Now the last part will have you write a piecewise, start with the absolute value function, my bad, and write it as a piecewise function. Well, the key to writing this as a piecewise function is to separate it at the vertex. So you might want to write that in your notes. The key to writing an absolute value function as a piecewise function is to set the parameters at the vertex, which is what we're going to do. So if I could start by just doing the parameters. Hey, Well, first got to start by doing the vertex, obviously. So the vertex is 3, 2, right? Opposite of -3 is 3, positive 2. So once I have the vertex, that x value is going to create my parameter. So I could write this right now. I'm going to do whatever function will create a line to the left of 3, and whatever function creates a line to the right of 3. Okay, now what does the a value, this number in front, have to do with creating those lines? They're very important, actually. The a value, the same value as the a value, will be the slope of the graph to the right. This is something you want to put in your notes. When changing a absolute value function to a piecewise function in linear form, the a value will give you the slope of the line as it graphs to the right. So notice -1 will be the slope of this line as it goes to the right. The -1 came from there. The opposite of that value, the opposite of the a value, so not the reciprocal, just the opposite value. So if it was -1, it's 1. If it was -2, this would be +2. The opposite of the a value will give you the slope of the line as it graphs to the left of the vertex. So the slope of this line is going up 1 and over 1, up 1 over 1. Okay? So that's the slope we're going to use there. Now I just use y equals mx plus b with this point and these slopes to find the y-intercepts. Remember, this is going to keep going, so it has some y-intercept up there. This one's going to keep going, and it's going to have a y-intercept down there. It's to find those two y-intercepts that we're going to do it. So we just simply put in the point 2 equals the slope going left. So remember, the slope of the line going left is the opposite of the a value. So I put in 1 times 3 plus b. So 1 times 3 is 3. Subtract 3 from both sides. b is -1. That's where that line is going to cross the y-axis. So y equals y equals x minus 1 is going to be true when x is less than or equal to 3. It's going to follow that line. Okay? Do the same thing, use the same point, use the vertex point both times, but use the different slope. So the slope is determined by this a value. Slope of the line graphing to the right is going to use the same slope. So this one is going to use -1 as my slope. Put in the 2, put in the 3 for x and y. Y always comes first. 2 equals -1 times 3 plus b. Well, -1 times 3 is -3. Add 3 to both sides. 5 is the b value. So my equation is y equals -x plus 5. Now I just sub that in for anything that is going to go to the right of 3. Now it doesn't. You notice I put the equal sign with the first one. It really doesn't matter whether you put the equal sign with the first one or the second one. It's going to be the same. But you can only have the equal sign as one of the two because it's in pieces. I got to cut it off somewhere. So I let the equal sign be with the top one on this one, but you can let it be with the bottom one. It doesn't matter. Just one of them will have an equal to, and the other one won't. Okay, but it'll always be cut off at the vertex. So that's how I got the 3. That's the vertex of the absolute value. Okay. If you need to watch this again, you can. It's just piecewise functions, Tom Hansen in YouTube. All right. Oh, your assignment. Your assignment's going to be 3 through 20 all on set 1.2. So this is 1.2. 3 through 20 all. And then 24 through 45, 4K, 4K plus 1 in your book. Thank you.